Let's find the mistake in box number 1. I need to first distribute. How do I know that? I have parentheses. Take the number in front of the parentheses and multiply it to everything inside the parentheses. So that is 3 times x, which is 3x. Okay. Done that, right? 3 times 3 is, 9, not 6. Looks like there's the mistake in step 1. Let's go ahead and look at the other side. Negative 2 times x is negative 2x. Negative 2 times 3 should be minus 6. Ooh, I dropped that. That should say minus 6. Negative 2 times a positive 3 is negative 6, so you write minus 6. And this one I added 3 plus 3 when I should have multiplied and made that 9. So the mistake was where? In step 1. Where's the mistake here? 6 times 5 or 3 times 5x? 3 times 5. Ooh, what did we write there? Minus 15. Ouch. That should say what? Plus 15. 3 times negative 2. Ugh, looks like I tried to add 3 plus a negative 2. 3 plus negative 2 is a positive 1, but we're multiplying. So this should say minus 6y. A positive 3 times a negative 2 is negative 6. This side is right. Step 1. Seems like we need to make sure we practice how to distribute correctly. Let's look here. Okay. Am I going to distribute 6 or negative 3? Negative 3. Negative 3 times 5 is negative 15. Woo! Negative 3 times negative 2 is a positive 6. Yep. Okay. 10 times x is 10x. All right. Now you notice that this is a positive 10, and I'm multiplying it to a negative 5. There's no negative on that number, so this symbol stays the same. And then that's 10 times 5, which is 50. So, yay! 10 times negative 5 minus 50. Same difference. So the mistake's not there. Where did the mistake happen? How did I get here? Forgot to bring that down. That means the mistake happened where? In step 1. You can't leave him off. And then there's also another mistake in step what? Y. You're probably thinking 6 minus 6, which is what? 0, so you don't see it. But it's not. It's 6 plus 6, which is... So honestly, the answer is step 1. But when you put that 6 there, it makes step 1 correct, right? So let's act as if the 6 was already there and we didn't forget to bring it down. Now why is the problem wrong for step 2? Because it's not 6 minus 15. No, these two terms don't have what? They both don't have a variable. This one does, but that one doesn't. It's not 6 minus 6. It's 6 plus 6. So you can only combine these two terms to get to 12. So, mistake, step 2. Let's just act as if that was a misprint, or I just forgot to bring down the 6. Three times x is 3x. 3 times 3 is 9. Good. You notice the sign didn't change, right? Negative 2 times x is negative 2 times 3 is minus 6. Good. This negative 2 times that positive 3, yes, gave me minus 6. Now, move the 9. No, what happened? Combine the terms that are alike. Oh, yeah, because I don't have an x over here. So the x was moved. Uh-oh. We're on different sides. Looks like, how did I get 1? 3 plus negative 2, okay. 3 plus signs. 2 negatives, cancel, 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 cancel. I have a 1 positive, but I have a 1 right there. What did I do wrong? They're on different sides, so you have to do this. That should be 5x, not 1. So the mistake is here. And if that's 5x, then this would be 5, and this would be divided by 5. So you know what? I can't say that step 3 is an issue, because it really happened in step 2, the mistake. And if I had fixed this here, step 2, if I had fixed it, then step 3 would be correct. So let me back up just a bit. This 6 should have been written here, okay? I wanted you to see that the mistake was in step 2. Now, how would you solve this? Hopefully, you would combine those by just adding, because they're on the same side. Over here, they were on different sides. Not so here. Now, move the 5 by adding. You get 12 equals 7x, because that cancels. Divide by 7. And the answer is, well, those cancel. X is 12 over 7. Let's do this one. That would be negative 2r plus 16. Bring the symbol down. We need to subtract 16. Okay, so do a little math by hand. I haven't done that in a while. We've been using that good old calculator. 4 minus 1. Check your work. Okay, we're good. Now divide by negative 2. What does that give me? Ooh, you divided by a negative. Whenever you divide by a negative, flip the inequality symbol. And so now what we need to do is to divide here. And so that should be 17 with a negative sign. Now what does that mean? Well, all R values that are below negative 7 17, excuse me, not including negative 17, but below negative 17 will satisfy this inequality. All right, now, a student bought concert tickets online. The total cost, C, in dollars, of T tickets can be found using the function C equals 2150 T plus 850. If the student spent a total of $73 on tickets, how many tickets did he buy? Well, if he spent $73 on tickets, where does the 73 go? In the C spot. Spent a total. Total is C. So how many tickets? What's T going to be? So I am going to remind you how to use the calculator. And we're going to go to the scratch pad, press menu 3-1, type in the equation 73 in one variable. And I'm going to use T because that's what's in the problem. Plus 850, comma, T because I used T. 3 is the answer. So how many tickets did he buy? 3 tickets. 3 tickets. Okay, so now let's set this problem up. It says a lot. I'm going to go straight to the parts we need. Okay, Chocolate Bliss sells 1 box of candy for $2 per candy plus a $12 packaging fee. I see per between $2 and candy, so that's letting me know to write 2x plus 12. This is the packaging fee. $3 per candy plus $10 for the packaging fee is what I write on the other side. And we'll talk about how we know that. Now, when will the cost of 5 boxes of Chocolate Bliss, 5 boxes, be the same? That's where the equal came into play. 5 boxes of Chocolate Bliss, when will it equal be the same as 4 boxes of the expressions in sweets? And so that's the answer. All I wanted you to do was set up the equation. Now, to be honest, I did ask, when will the cost be the same? So there is one more step. So to answer this question, and not what I just wanted you to do, I'm going to be honest, I wanted you to set it up. So I should have just erased this last sentence and said set it up. Hint, hint. However, to answer the question, go ahead and put it in the calculator. And you get 10. 10 is x. So what does x represent? Simple. X is sitting by the 3, x is sitting by the 2. So what's sitting by the 3? Oh, $3 per candy. $2 per what? Candy. So when x is 10, all of that times 5, when x is 10 here as well, the cost for both will be $160. So when will the cost be the same? Well, the cost will be the same when you have x equals 10. Okay, good luck.